Okay, welcome to the Vision Brick. In this video, I'll show you how to train custom YOLO object detection models. I have an article about this. You can watch the video or follow this article. Everything is same. So let me show you what are we going to do quickly. First, we will set up our training environment. Then we will create a dataset. After that, we will create a YAML file. Then we will choose a pre-trained YOLO V8 model. Then we will create a Python file for training and we will train our model. You see the training process. And last step is we will test our model. You see detection of chess pieces. So we can start. Okay, first step is training environment. If you don't have GPU supported PyTorch environment in your local computer, you can directly use Kaggle or Google Colab. They offer free GPU. You just need to upload your dataset and activate GPU. After that, you can train your models quickly. Or if you want to create a GPU supported PyTorch environment, you can follow this video. I watched this video like 1 year ago and I still use the same environment. If you have NVIDIA GPU, you can watch this. So what is that? Okay, nothing important. Okay, create a dataset. So I'm not gonna create dataset from scratch because it will take so many time. I will directly use this dataset. I found it from RoboFlow. I choose it randomly, like there is millions of datasets. I will show you some examples. You see BlackRock, Blackpound. You see the dataset is already augmented, so no need to additional augmentation. You see this image is rotated, for example. These are labels. Okay, you can download this dataset from here. You need to come to the dataset section, then download. Here a zip. There are like different formats, you know, Coco, for example, Pascal. I will choose YOLO. Continue. Okay, I already downloaded this dataset before and I copy the zip file here and extract it to here. You see there's three main folder: test, train and valid. The format is same. Under train there's image and label folders. It's same for validation and test folders. I'll show you one example. For example, here txt files format is like that. First number is label ID and others are positional information. And in image folders, they're, you know, these are images, nothing more than that. Okay, I can close this. Okay, other step is create a YAML file. YAML file basically contains information about your dataset. You see there's two paths here, train and val. These are path to the train and validation folders. This 12 represents the number of class. And here you can see the class names. I created this file chesspeak.data.yaml here. You see, you can directly create, by the way, like this, and write whatever you need. Now I will delete this. Okay, nice. Choose pre-trained YOLO model. You don't have to stick with YOLO V8. You can train YOLO V11, 12, 10, 7, 8, whatever you want. With Ultralytics, every step is same. By the way, I'm not sure about YOLO V8. It must, yeah, it is a little bit different than other versions. But after YOLO V8, you can train 10, 11, 12 exactly with same steps. So you need to download this pre-trained models, one of them. You can find pre-trained models like this, GitHub YOLO V11, for example. You see there's comparison of other models. Okay, this one is nano, small, medium, large, and X. I think X large, but I'm not sure. You see the number of parameters and other, for example, accuracy. You see, I'll stick with the nano model because I don't have a powerful GPU and I don't want to spend so many time. So, but you can choose anything, you know. But it will take more time if you choose, for example, large model. You can directly click whatever you want here and it will directly download it. After download it, copy the model to your base folder. Here I copy it. Okay, We can move on. So create a Python file. Okay, here we will, this is code for training. But before that, let me import PyTorch. Okay, I have this version, you see. This means that this is GPU supported environment. If you try to train with your CPU, it will take maybe weeks. I don't recommend that. Like nobody recommends that. Okay, we can see my GPU here. You know, this is an old one, but still works. Okay, here is our training script. First, I am here loading pre-trained YOLO model. You see, the same as this. I can directly do this, by the way. We are in the same directory because. Okay. Then here you can see the YAML file. This is image size. You can change this value, but you probably see all the time 640. But this is not a rule. You can change this. For example, if you have smaller objects, you can increase this value. It will be better for you. Here, epoch number, I'll set this to 10 because I don't want to spend so many time. Even with 10 epoch, you know, it took about 1 hour. But you can increase this with, if you are using Kaggle or Google Colab, yeah, you can increase this and it will not take that much time. Yeah, I set batch size to 4 again because of my GPU's memory. I set this to 4, but if you have like better GPUs, you can set this to 8, 16 or 32 depending on your GPU. This name is output folder name. Basically all of the created files will be under this folder. Your model, your curves, all of the metrics. So okay, other parameter is plots. You can set this to true. It will give you some plots about precision, recall, and other like loss function, like loss values and other things. I think it's pretty useful. And I set this to false because it gave me some error. Again, because of my memory, GPU's memory. You can set this to true. Okay. You can see the backbone of our YOLO model. You see there's some errors, but nothing nothing important, like duplicate labels, like no problem. You see all of the training process here. You can see the loss values and accuracy values. For example, one epoch take approximately 5 minutes, and in total it took 1 hour. Okay, it saved our models to this directory, and you can see all the metrics for different classes from here. You see. Okay, and let me show you something. Under this name, chess model training 1 runs, chess model training 1, you will see a bunch of files. These are example images from training process. You see, this CSV file contains all the necessary information about your training history. You see classification loss, box loss, time to train that specific epoch, like recall values, other things. Let me show you, even learning rate. Yeah, you can, like everything you need is under the CSV file. And there is already, you know, we set plot to true. Like, let me show you. You can see these curves are created directly, automatically. If you set that to false, there won't be plots like this. I think they are pretty useful. You see confusion matrix. These are true detections. And most important, there's weights folder. You can see there's two model. I'll use best.pt for testing model. I think there's nothing to say, we can test the models. Yeah, here best.pt model, and I'll choose test image randomly from test set. I'll choose complex image, yeah, like this one. Okay, come here. Okay, here's the result. We can look black rock, white pawn, white rock, white knight, white king, white pawn. I think it's pretty good, like black pawn, black king, black knight. Okay, we can do a few more. Maybe find more complex images. Yeah, this one is like orientation is not good, so we can test this image as well. Okay, yes, black rock, black king, white king. Okay, we can do one more. Yeah, this one is interesting as well from top. Yeah, perfect. You see, black knight is true, white rook is true, pawn, pawn, pawn. Okay, I think there is nothing more to say. Thanks for watching the video. See you soon.